All right, so this is our first learning guide for calculus, so Math 31. We are going to start off with actually a little bit of a review. We're going to talk about factoring, we're going to talk about rationalizing, and then we're actually going to get into something called limits, which is, again, you can kind of see part of our title here. So the first little bit of factoring that we're going to look at is actually a little bit different. Normally we've seen PSA 1, PSA 2, difference of squares. Those are kind of the most common ones. The one that we're going to start off with is actually the difference of cubes. So instead of difference of squares, sum of difference of squares, we're now looking at cubes, which is a little bit different. You can see here that I've got two formulas. And these are on your formula sheet, so you don't need to memorize them. And these basically, guys, we've got two terms that are perfect cubes, and we're adding in the first one. And in the second one, we've got two perfect cubes, and we're subtracting. So what you want to do, if you take a look at, let's say, example number 1, you want to look to see, okay, I've got two terms. They're both perfect cubes, meaning I can take the cube root of them, and I've got a minus sign. So that automatically tells me I'm going to be using my second formula there. So first thing we want to identify is, okay, well, what is A? Because you'll notice that we've got A's and B's here. So what is A and what is B? Well, in here, notice that it's A cubed. So in order to find A, I need to take the cube root of my first term, and that's 8x cubed. So when we take that cube root, again, basically the cube root of 8 we know is 2, and the cube root of x cubed is just going to leave us with x. The second term, b, is going to be part of this guy, 125y cubed, but again, in order to find just b, we need to take the cube root of what we see, which again is 125y cubed. So we're going to do the same thing. The cube root of 125 is 5. The cube root of y cubed is just going to be y. So now we found our A and our B. All we have to do now is look at that formula. Okay. So I've got basically A minus B, so 2x minus 5y. And then I've got a squared plus ab plus b squared. So a squared is going to be 4x squared plus a times b, well, that's going to be 10xy. And then I've got my b squared, which is going to give us 25y squared. And that's it. So we can take a look at that. That is the factored form of what we started with. And again, that's the factored form of a perfect cube, or the difference of cubes. Let's take a look at number 2. In this case, again, we identify that we've got our two terms. So I've got 64x cubed and 1. Again, note that they are both perfect cubes, meaning we can take the cube root of them. But in this case, we're adding. So that tells us that we're using this top formula here. Again, the first step, guys, that you want to do is figure out, okay, well, what is my A and what is my B? So I'm just going to get rid of this out of the way here. And we know that A means I'm going to need to take the cube root of my first term, so 64x cubed. So that's obviously going to give us 4x. And then for b, this one's easy. The cube root of 1 is just going to give us 1. Now again, just follow that formula. So now we've got a plus b. So again, it's just going to be 4x plus 1 times the next one, which is going to be a squared. So that's going to give us 16x squared minus, in this case, a times b, which is just going to be 4x times 1, which is 4x, and then plus b squared. So that's 1 squared, which is 1. And that would be our factored form. If we carry on, looking at now the difference of squares. This is something that should look very familiar. You guys learned this actually back in 10 Common. And if you remember how this works, you've got your x squared minus y squared. And basically, like what we did with the cubes, all we're doing is we're taking the square root of that guy, which is x, and the square root of this guy, which is just going to be y. And because it's saying the difference of squares, we know we're going to have a different sign in there. So 1 plus and 1 minus in whatever order you want. So using that identity, we'll do a little bit of a practice here. So number 3, again, notice I can take the square root of both of those, and there's a minus sign, which is good. So I'm going to draw my 2 brackets. The square root of x squared is x. X, square root of 9 is 3 and 3. Again, 1 plus and 1 minus. And that's it, just as simplified as we can do. The next one, again, you'll notice has 2 terms. What you won't notice in this case, which is a little bit different than what you learned in previous years, is that this is not a perfect square. So right away in previous math courses, we've said, okay, well, it's not a difference of squares because that's not a perfect square. But what we can do is actually just take the square root of this and leave it as it is. So take the square root of that. We've got x and x. The square root of 20, we can literally say, is the square root of 20. And again, 1 plus and 1 minus. Now this is, it's good what we've done so far, but it's not fully complete. It's not fully simplified. If you recall how to reduce radicals, remember what we need to do. Now there's many ways of doing this. We can take our square root of 20, depending on whose class you were in and what method you learned, and whatever your preference is. Like I said, there's many ways of doing this. Probably the most common is to break this down into its factors. So let's say 2 and 10, and then 2 and 5. And because we have a group of 2's, that's going to simplify to a 2, and then we've got the square root of 5 left over. You may also look at this as the square root of 4 times 5. Okay, this is the kind of method number 2. And the square root of 4 is 2, and then we'd be left with the square root of 5. So whichever way you do it, it's still going to give you the exact same answer. So if we know that this is actually the simplified form of that, our final answer is now going to be x plus 2 root 5 times x minus 2 root 5. And that's going to be the final simplified answer. The next question is exactly the same. So I'll just do this one kind of quickly. Again, difference of squares. Take the square root of everything. It's going to be 5x and 5x. That one's easy. The square root of 8. Again, it's not a perfect square, so we're just going to write that down. 1 plus 1 minus. Remember, square root of 8, we're going to reduce it. So that would be 2 and 4, and then let's say 2 and 2. Group of 2, which is going to be 2 root 2. Or, again, you can look at that as 4 times 2. Square root of 4 is 2 root 2, whichever way you prefer. And then we're going to have a simplified version here. So 5x plus 2 root 2, and then 5x minus 2 root 2. And that would be, again, just a review of our factoring the difference of squares. The next thing that we're going to get into is factoring expressions with rational exponents. This is new. You haven't seen this before. And rational exponents are kind of self-explanatory. They're basically fractions in our exponent. And basically what we want to do is we want to factor. Now you guys are really used to things like PSA 1 and PSA 2, obviously the difference of squares, now difference of cubes. And we're still going to use all of those identities, but what we have to do is get rid of our fractions in our exponent. We don't want them. And so there's a little rule that you guys can remember. We'll just read through it together. It says when an expression has rational exponents with variables in its terms, so again, rational exponents just mean these guys here, these fractions, okay? The variable, this is important, with the smallest exponent should be factored out of each term. So basically what this is doing is it's finding a GCF. And when you found that GCF, what you're going to do is divide all of the terms by that GCF. And what this is saying, this little rule, is your GCF is always the variable with the smallest exponent. So let's look at an example number 6 here. Take a look. I've got 5 over 2, 3 over 2, and 1 over 2. Obviously, the smallest exponent would be this guy here. So that means what I want to do is factor out that smallest exponent. And now what we're doing is we're dividing every term by that. And if you guys remember, how do we divide exponents? We subtract them, right? So everything here, basically I'm subtracting a half from it. Okay, so I'm going to take my 2a, and now I've got 5 over 2 minus 1 over 2. Well, that's going to be 4 over 2, which would just simplify to 2. Then I've got plus a, and 3 over 2 minus 1 over 2 is 2 over 2, which is 1, minus 3. And then we've basically got a, and I've got a half minus a half. Well, that's 0. And remember, a to the power of 0, or anything to the power of 0, is 1. So what's actually happening here is we're basically just canceling that out. And now when you look at this, it looks a little bit nicer because we have a trinomial inside of our brackets that we can factor using PSA2. And it's PSA2 because of this guy here. So remember how to factor this, just as a little review. So PSA2, I take my 2 times my negative 3, which is negative 6, and I'm looking for the factors of negative 6 that add to that middle number, which is 1. So I have my positive 3 and negative 2, and that's going to give me the answer of 1. Now with PSA2, it's kind of a pain in the butt. We have to rewrite our equation. So I've got my 2a squared, I've got plus 3a minus 2a minus 3. And now we factor by grouping. So I'm just going to cut this in half, and I'm going to take a look at my first 2, and in here I can factor out an a. So I'm left with 2a plus 3. Over here, you always want to take this sign, whatever it is, and bring that down. And there's really nothing that we can factor out of 2a and 3, so we're just going to take out a negative 1. And then we draw our brackets, and all that's going to do is change the signs. So that's going to become a positive 2a and a positive 3. And remember, this is our checkpoint. If what's in those brackets is the same, you know that you've done a good job. And we're going to rewrite them. We're going to combine that as 2a plus 3, and then whatever's left, which happens to be a minus 1, goes in the other bracket. So that's the factored form of what's inside the bracket. So basically I've taken this and I've used PSA2. What I don't want you to forget is that we've already factored out that a to the power of a half. So don't forget to bring that down and include that in your final answer. So a little bit more of a pain in the butt, just because there's some more steps that we need to think about with that PSA2. Let's take a look at number 7, because again, I don't want you to lose sight of what we're actually trying to accomplish here. We're factoring when I've got a fraction in my exponent. So again, you want to think, okay, how do I get rid of that? What's that rule? Remember, we go up, the smallest exponent should be factored out of every term. Okay, so let's take a look at number 7. Obviously, the smallest exponent there would be that negative a half. Now, if we look at the numbers, there's also something else that we can pull out, obviously a 5, right? So we're going to divide out a 5 and an a to the power of negative a half. And then we can figure out what's going to be left over. Well, remember that we are subtracting that exponent. So if I'm subtracting negative a half from everything, okay, that's what we're doing here. That first exponent, remember the 5 is basically going to cancel out. So I'm left with a 3 over 2 minus negative a half. Well, that's going to become 3 over 2 plus a half, which is 4 over 2, which would just become squared. Minus 20 divided by 5 is going to leave us with 4. And these exponents, guys, are always going to cancel out, right? Because we're basically subtracting itself. So that's going to be gone, and we're left with this. Now, you always want to double check your brackets before you say, okay, I'm done. And what do you see there? 2 terms, both perfect squares. We just practiced this. This is the difference of squares. So I'm going to keep my half. And this is like the easiest factoring ever, which is good. Take the square root of that guy, which is a and a. Square root of this guy, 2 and 2, 1 plus and 1 minus. And that would be our final factored answer. One last example. I'll just go through this one really quick. Here. Again, don't forget the rules. What we want to do is basically find the smallest exponent here, which is going to be that 3 over 2. And in this case, rather than just having one variable to that power, we actually have a binomial that we can factor out. And everything works exactly the same. So I'm going to take that x plus 2 to the power of 3 over 2 and draw my bracket, because we're dividing that out, because obviously these are common. I still do the same thing, so I'm going to minus that 3 over 2 from both of those. So 5 over 2 minus 3 over 2 is going to be 2 over 2, which is 1. So we're just going to have x plus 2 to the power of 1. And then I've got minus 3 times this guy, which remember is going to be to the power of 0, which is just going to disappear, going to cancel out. So we're left with that. And then obviously here, guys, we can simplify. We don't really need these brackets anymore. So I've got my x plus 2 to the power of 3 over 2 times 2 and negative 3. That's going to become x minus 1. And that would be, again, just our fully factored form. If you take a look, there are more examples here. And again, I'll just kind of go through these really quickly with you. And don't forget, this is a podcast. So if you guys are feeling like this is pretty easy, you can move on to the next slide. Or for extra practice, what I might do as well for you is, if I were you, I would probably pause it, try these questions 9 and 10 yourselves if you haven't been doing that already, and then just kind of fast forward to the answer to make sure that you see that. So again, I'll just kind of go through these quickly for you. Smallest power is this guy. I've got my x plus 4 to the power of negative a half. Draw that bracket. I'm going to leave my x plus 4. So again, we're minusing negative a half. Minusing negative a half. So this is going to become x plus 4 to the power of 7 plus 1 is 8. Over 2 is going to be 4 minus 4. X plus 4 to the power of negative a half. And we're left with, here, kind of like our difference of squares. If you want to take a look at this one's a little bit trickier. So again, you'll notice that this is a perfect square and that's a perfect square, meaning I can take the square root of this. So I'm going to have x plus 4 squared, x plus 4 squared, and the square root of this, plus 2, minus 2. And again, we can just kind of simplify things. One thing that you'll notice on your assignment is that when you have multiple choice, your answer might not exactly match the answer that's on there. So what you want to do is be able to manipulate it. So notice that you've got a negative exponent. Whenever you have a negative exponent, those can always go down into the numerator, or sorry, the denominator. So I've got my x plus 4 squared plus 2, x plus 4 squared minus 2, divided by x plus 4 now to the power of positive 1/2. And that would be a fully simplified answer, fully factored. The last one here, number 10, again, what we want to do is basically be able to kind of factor first and then see if we can simplify. So you'll see that we've kind of got a fraction here with our exponents that are fractions as well. So the first thing, again, don't forget your rules. We take that negative a half and we want to factor that out. So I've got my 2x minus 5. Factor out negative a half. Draw my bracket. So remember, we're minusing a half from everything. Minusing a half. Sorry, negative a half. Okay. And basically, we're adding. So a half plus a half is going to leave us with 1. So I've got 2x minus 5 to the power of 1 plus 4. Because remember, that's all going to disappear. All divided by 2x minus 1. Now let's simplify. You'll notice here that I don't even need these brackets really anymore. So I've got 2x minus 5 to the power of negative a half times 2x minus 1, all divided by 2x minus 1. Well, if you take a look, what is something that you can cancel out here? What's working? Well, I've got 2x minus 1 and 2x minus 1. So we're just left with 2x minus 5 to the power of negative a half, which again, don't forget, you could also write as 1 over 2x minus 5 now to the power of positive a half. Okay? All right, so what you want to do now is make sure, obviously, you understand everything. If you have any questions with anything, go to the help desk. And you want to practice this. So in your textbook, you want to turn to page 3, practice all of this, and then obviously you can get started on your assignment as well.